So I told you I was going to come and talk to you about the future of workstations today. And I'm going to give you a glimpse of something that I want to be real clear, it does not exist, but it's very cool. It's some research that we're actually doing at Carnegie Mellon University. Today it doesn't at all look like this. Today it's the size of tennis balls, okay? And just like those helicopters that you saw this morning, they know how to reconfigure themselves and do interesting things. And if you go back to that video that you were just watching with Mark Bohr, and you know that Moore's law continues on and on and on. We actually know how to get it to 4 nanometers, which is impressive. We have to go through a few more material changes along the way, but we know how to get it to 4. And when you get to 4, things like this almost become possible. So we have to figure out how to keep going on that. So this is just kind of an interesting thing of what technology might be able to do for you. And this is kind of far out. This would be like 2025, 2030 kinds of opportunities. But kind of cool stuff that Intel's engaged with at a number of locations. So, pardon me? Yeah, I'm hoping I am too, by the way, just so that we're on the same page. So, and then just to put a little humor on it, this is.
Well, at first I thought I'd get into the memory circuit, but that's silly, right? We are Intel, sponsors of tomorrow.
And we do that.
Well, at first I thought
that's our parties at Intel right there, guys. And it's kind of, we take a processor, put it on a cake, and we chop it up, and then other engineers go, "You can't do that, man. You just can't do that." So let's see if we can get here. And I know I have an animation or a video at some point in time. Can everybody hear me? Are we good? I have 6 business cards in my pocket. I tell you that because I didn't bring any solid-state drives with me today. I apologize. I tried to get in my office over the weekend. Actually, I have 4 business cards, so that makes it a smaller number. I tried to get into my office over the weekend, and I thought I had always accessed. And, I was not able to get in and pick up the solid-state drives. But for those of you that are active, with the exception of you, for those of you that are active in questions, answers, participation, I have 480 gigabyte solid-state drives that I will ship you. That's roughly a $500 product. So I call it a paperweight because that way I can give it away to you. If you happen to put it into a PC, a laptop, or a desk-side system, that paperweight can become an amazingly interesting thing. And it's what we did with the folks at SolidWorks Engineering and their R&D. You heard Vajrang this morning talk about how they love solid-state drives, okay? If you're doing software development, you're going to love solid-state drives because you can build and save and build and save. It's almost infinitely fast. And so in environments like that, solid-state drives are out of sight. In the day in the life of a typical enterprise worker, that would be me. I'm not an engineer doing chip design. I do PowerPoints. I do searches on the web. I do lots and lots of email. And for a guy like me, a solid-state drive, and you can go on YouTube and download this one, but a guy like me, solid-state drives will give me roughly 3x increase, over a 3x increase in my productivity during the day. Measured, validated several times across a bunch of different workloads on the day in the life of an enterprise worker on that one. You feel the difference. You do on that one. So I can't say enough about solid-state drives. So we're going to talk about 2 things here today, okay? And the first thing we're going to talk about is something that you've been hearing about from a number of people. So what makes the right workstation? Okay, I work with Intel. You'd think I would tell you, buy my biggest and fastest processor. I'd like to tell you to buy my biggest and fastest processor, but I want you to make the right investments, okay? And there's a balance. Frank Soke this morning talked about, is it this morning? Yeah, I guess it was this morning. He talked about the balance, and Seymour Cray. And actually, he had the quote a little wrong. Seymour was asked to comment what it is that he does for a living. And he told the reporter, he said, I'm a plumber. And the reporter looked at him and said, well, what do you mean I'm a plumber? He said, well, I plumb data, right? Anybody can build a fast processor. Anybody. That's not the hard part. The problem is building a fast system. And at Intel, when we look at our processors, we just don't look at what a CPU can do in terms of floating point and integer performance. We actually look at how do you plumb it differently, okay? And one of the things that you'll find out in the difference between an Intel Xeon-based workstation and an Intel Core-based desktop is that there are some significant differences, okay? And I don't have a slide on this, but we'll talk about it real quickly. The big difference is that when you buy a Xeon processor, it's got what we like to call the Uncore technologies, right? I mean, if you really think about Intel, every processor is based on the same technology, right? Sandy Bridge, Ivy Bridge, or a future generation called Haswell. They're all going to have the insides of the processor are principally going to all be the same. What the Uncore technologies is it's the plumbing, back to Seymour Cray, remember? It's the plumbing that goes around a processor, right? And Xeon is actually architected for servers. It's architected to handle large data. It's architected to move large data quickly and get it to where it needs to be as quickly as possible so that you can act on it. Now, what's your name again? David. And so let's imagine that David's the processor and I'm the I/O, right? Now, in a typical core-based desktop, I'm the data and I want to get someplace to memory, okay? I'm going to say, hey, David, let me go to memory. Hey, David, let me go to memory. Hey, David, let me go to memory. Now, what the Uncore technologies will do is I'm not going to say anything to David, but I'm going to go through a processor and I'm going to get to the memory faster because I'm no longer interrupting you. I'm also allowing David to compute. So it's a win in a number of ways. In terms of the I/O operations, and it's a win in terms of what the computer, the CPU, is actually doing. And that's actually a really old technology. I started 32 years ago with controlled data. We had, in our systems, we had these things called network processing units, which did the same thing. It took the I/O traffic away from the processor and then allowed me to go directly to memory as opposed to interrupting David all the time. So let's get going with the presentation. So we're going to focus the first part of the presentation on what a workstation really needs to look like to deliver the best potential experience, okay? And so, I always go, did you know, right? Through a number of studies, we actually found that a CAD-only user really benefits from a machine that's between 4 to 6 cores. Proven, validated through a number of resellers here at SolidWorks. And so we're pretty easy to talk about 4 to 6 core workstations. What that means is when you're looking at workstations, you're going to consider between an entry-level workstation, which does not have the Uncore technologies, and then a mid-range workstation, and I'll give you the product numbers at the end, a mid-range workstation which will have a Xeon E5 class product in it, and that'll come with the Uncore technologies, and you'll see different levels in performance. Now, the other thing that we found through a number of tests is that insufficient memory can dramatically decrease your performance. The rule of thumb is whatever your largest model is, buy twice the memory. That's the easiest way to get you to the best performance. Okay? The other thing that we found, and then through a number of tests, is that solid-state drives, while albeit they're expensive, can increase your productivity for CAD and engineering by 2x. So we would suggest that you look at doing that, okay? And then at an entry-level workstation, we have this thing called Intel HD P4000 graphics, which is integrated right onto the processor. And what we find with our engineering folks here at SolidWorks is that they actually believe that it satisfies more than 90% of their users' requirements. Question? Yeah. Yeah, so, okay, I'll rephrase it. Okay, so he's asking the question, what's the difference between Intel HD 4000 on a Core i7 desktop versus an Intel HD P4000 on a Xeon-based workstation, okay? A good question. I'm glad you asked it because I always forget to tell people about that. It's no different than buying a graphics card from NVIDIA or AMD. They have consumer-grade products and they have professional-grade products. And if you look at their silicon, it's just like us. It's the same silicon, okay? Now, what the P does is it means that there is a performance or a professional driver that's associated with it. It goes and unlocks additional trapdoors for DX and or OpenGL performance. Okay, it's not what you typically find on a consumer-grade graphics cards. And if you're a gamer, by the way, it doesn't hurt. It doesn't help either. But that driver doesn't hurt your gaming environment in case you want to play games. So you get everything that you get with the HD 4000, but you get professional drivers that are there and modified to make applications like SolidWorks operate better. Does that make sense? But thank you for asking the question. And I know you're in Israel, right? So getting you a solid-state drive, that's one that I moved over, and I've got 3 more to go. Getting you a solid-state drive to Israel is harder, but I'll see what we can do to figure it out. I can't make any promises there because it's just a pain in the rear to get it out of the country. Not necessarily into your country, but out of your country. You have a question?
I do. What's the impact of the P4000 graphics card if your rendering program uses nothing but cores primarily?
None.
None.
Doesn't impact it at all. You get the same performance.
Spending extra money on a high-end graphics card if you're going to be doing rendering that's done using the chips.
That's a good question. So your question is, where's the rendering being done? Basically, right? Excuse me, Intel I'll just shorten it. P4000 will give you something less than a Quadro 600, okay? A Quadro 600, something less, okay? But Caddy, who actually gave a presentation in this room yesterday, did the test last year, and what they found is that anything between a Quadro 600 to a Quadro 6000 at that time gave a 6% difference in performance. Really? Right? I was in another presentation, similar topic. Everybody thinks that you got to get this big Mambo graphics card. Remember, at the beginning of the conversation, we talked about balance, okay? And so that's why I want you to invest in balance. I tell you to buy the biggest and baddest processors. You could. I'd love you to. I want you to have balance. I want you to get the best user experience, okay? And there are other things that you could be investing in that actually expand your performance better. Memory, solid-state drives, faster CPUs, and then graphics. Probably in that order, by the way. Okay? And I'll move a card from over here to over there. So make sure you come by and pick up the card. I'll put an IOU. If you don't get the solid-state drives in the next 3 to 4 weeks, send me an email. It just means I forgot. Okay? Yeah. Absolutely. The question is the P4000 certified by SolidWorks? The answer is yes. And again, I don't want to oversell, undersell something. I mean, this is an ideal solution for a guy that's just doing small to medium assemblies. If you're doing the really large assemblies, go get yourself a Quadro 2000 graphics card, and that's what you should be doing, okay? Pardon me? Yes, it will. Dual monitor support, yes. And there'll be more monitor support in the next generation. I can't give you specific numbers because I can't announce anything, which is really hard for me to tell you. I'm going to tell you about the future if I can't give you, but I'll show you a video. I don't know the number on that one, but it's as good as any other graphics card that you can buy. I mean, it's not any worse than any other professional graphics card that's out there. So, question was on graphics resolution, same amount on that one. So the other one. So we talked about the Encore technologies, and so then the other thing to realize is that let's see. SolidWorks and almost every other CAD application, for the most part, is single-threaded. And why do you need all those cores if they're all single-threaded? Well, because you're doing a bunch of other things concurrent with everything. And don't kid yourself, you are. Okay? That's why through a number of tests with the resellers, they said 4 to 6 cores if you're doing CAD only. If you start to look at photorealistic imaging with PhotoView 360, or if you start to do simulation, you actually want to then be considering 6-core, 8-core, probably dual processor to get to 16 cores on that, and I'll show you some benchmarks as we move through that on that one. So you buy down because you don't appreciate the value. My job is to understand how to help you understand the value. From a reseller perspective, it's really high on our list because how many of y'all are customers as opposed to resellers in the room? It's my understanding you probably get most of your information from the reseller about what you might want to consider to buy. So if I can get him to get more knowledgeable about what it is that you should buy, you'll be better off. If you're spending $6,000 on SolidWorks, or if you're spending $15,000 on SolidWorks Premium, if I could get you 2 or 3x more of solutions, if I can get you 2 to 3 times more answers back in the same time, I just increase the value of your software. And you need to be thinking that way as opposed to just raw cost on that one. If the value of iterating has anything to do to your business, then you need to be figuring out how you iterate through more designs in less time. Everybody's talking about the cloud. A wonderful idea. I've got lots of gray hair. I've been around the business for 32 years. When I started, it was called time sharing. Time sharing is not free. My electric bill has never gone down. The cloud is not free. And as long as you understand that the cloud is not free, then my recommendation is, and if you were here when the Disney thing was going, or the DreamWorks thing was going on, my recommendation is that what you do for simulation and or ray tracing is you get to a situation where you know it's going to converge on the solution that you want it to converge on. Because then when you send it off to the cloud to do a finer grained simulation, you know the odds of getting a solution that you care about back is better. Therefore, you made better use of your money because you're going to spend the money to go out to the cloud. And if I can help you get a better result because you did some level of simulation local, then the better off we're all going to be. And David, I'll move a card over to here, too. So there's one left. So balanced configurations. Frank talked to you about balanced configurations. Rob Herman from Lenovo talked to you about balanced configurations. So processors, speed, core numbers, those are the things you want to pay attention to. Overclock or not overclock, that's a debate that's out there. We'll talk about balance and the need for balance and all total investments about what you're looking at. Other investments that you need to be doing, we talked about the memory and the impact of memory. If you don't buy the right amount of memory, if you starve your memory, you'll cut your performance down in half. It's a given. Solid state drives, again, because you're opening and closing things all day long, just because of the way you work. Even if you open a large assembly and you live in that assembly all day long, you're going to save it a lot of times. Just because of the way you work, it's probably going to deliver you 2x more increase in productivity on a daily basis, okay? And so remember, system balance, Seymour Cray, build the balanced system, get a better solution. I always talk to people about a three-legged stool. Have you guys heard this three-legged stool story before? Okay, so the three-legged stool story is kind of short, but it gets to the point really fast. Imagine I'm trying to reach a bag of flour on a very top shelf in my kitchen, and I'm on a three-legged stool with one of the legs on the stool 4 inches taller than the other one. Now, if I get up on that stool, I get up on my toes, and I reach for the flour, what's the likely outcome? Anybody? Who said that? You already answered it. Okay, you're going to fall. You're going to look like a ghost because the flour is going to go all over you. Well, the same thing's true with a workstation. If you don't configure it correctly, you're not going to like the results. So my recommendation is that you look at the configuration and you say, what's going on? So now this is a good question, right? This is an Intel question. It says, so when do you benefit from a workstation with 2 processors? Remember, here's an example of a, let's see, does it have, it doesn't have all the processors in there. Here's an example of up to a 16-core workstation, okay? Now, when do you benefit?
Photorealistic rendering.
What?
Photorealistic rendering.
4 ways to...
Photorealistic.
Photorealistic imaging. Absolutely good answer, okay? Because it is multi-threaded, okay? Now, do you think you'd benefit from it if it was single-threaded? Now, this is the way Intel works. Now, we are hell-bent on Moore's Law and keeping it alive, okay? And some of more than you'd like to think of our simulation packages bought from third parties or even internal are still single-threaded, okay? There was a professor over in the Netherlands, he's one of the gee whiz guys of computing science, and he said, writing an application that's single-threaded is hard. Writing a multi-threaded application is a big step beyond that. So it's hard, right? So we still have lots of single-threaded applications. Well, what we did is we did a study, and it said if you're running single-threaded applications, you can actually do pretty good. You can actually improve your performance or your productivity because you can actually run more than one at a time. So you have to adapt what your workflow is. You don't think, I'm going to run one model at a time. You think, I'm going to go run 16 models at a time. And this is what we did at Intel. Okay, so we looked at machines that were, 1, 2, 3, 4 years old, and we said, what's the difference in what we're getting done with single-threaded applications? And we got over a 4x increase in performance because we adapted on our workflows, on how we worked and used the available compute capacity. So even though you're going to have applications that might be single-threaded, the point is take advantage of all the processing that's available. It might mean that you need to buy more memory. It might mean that you need to buy another solid-state drive. If you're getting more answers back in less time, trust me, the small investment that you're going to make to do that is going to be well worth what it is that you're talking about. And so I'll breeze through this real quickly just in the essence of time, but if you look at ANSYS, which is a competing product to some of the SolidWorks stuff, you get a 4x increase, performance improvement. Photorealism, using Luxology, sounds familiar, Moto. Plug-in for SolidWorks, you get a 2x increase in performance, and then in financial services, you can get a 3.5x performance improvement. These are all with multi-threaded applications. Now, we've been doing some really cool work with our buddies here at SolidWorks in the area of their solvers and whatnot. And it's not in their product yet, and I can't give you the numbers that we're talking about, but we're really excited about some of the things that we're doing with SolidWorks and our opportunity to continue to scale across more cores. So when do you need a single-threaded processor? If you're infrequently megatasking, yeah, you can probably live with it. If all you're doing is CAD, you can probably live with it. If you're only occasionally doing ray tracing or modeling, yeah, you can probably live with it. But if you're doing any amount of ray tracing and modeling, you're going to do more. And so I would tell you to err to the side, make the added investment, learn to explore what's possible with simulation. And I sat down, you have a question? We have. We didn't do it with 1 8-core against 1 8-core single processor. Did we? Yeah, we did. I don't have that data here, but this is something similar. This is looking at, looking at Abacus, which is part of the Dassault family, and it's taking a look at what's the impact of solid-state drives and what's the impact of adding either a second processor or GPU from somebody. Okay, and what we find here is that solid-state drives in memory make a dramatic performance improvement in what's capable. The other thing that we found here, and it's pointed out here, is that adding a second processor gives you a great deal of opportunity to increase your performance. What this particular chart is showing you is that it gives you more performance over a broader spectrum of usage models. It's giving you the flexibility. Now, to be candid, and I'll use, her name is Kathleen Yelnick. She's the director of computing at NERSC, which is one of the national energy research laboratories in the country. And she's got 600 users. And she compares herself to Sandia, which is another national laboratory. And the difference that they've got is that what Kathy has to do is she has to support 600 users with 1,200 different kinds of applications. And what Sandia is doing is they've got to support probably the same number of users, but with only 2 or 3 different applications. And it's just a difference in how you go about making that decision on your investment. Okay? If you're doing the same thing over and over again, and it might benefit from certain accelerator technologies, then by all means go make that investment. If you find yourself in a situation where you're doing lots of things, not always the same thing, more like Kathy Yelnick at NERSC, then do yourself a favor and buy or invest in the second processor. It gives you more performance than the accelerator technologies that are out there, and it gives you the greater flexibility to go after a number of other problems. And so that's just kind of a rule of thumb that's going there on that one. So
the reason I ask is,
yeah.
My experience has been that a 4-core processor typically has a higher clock speed.
Okay, good question. I didn't look at it that way.
So if you have 2 4-cores, you theoretically have higher clock speed for each.
Good question. Let me go after that one for you. So I'll repeat the question, just to make sure I got it right. So if I take two 4 cores at higher frequency going up against an 8 core with a lower frequency, am I apt to get better performance? Is that the right question? I'm going to throw another twist into it. Typically, the 4-core processor is going to be an older processor from Intel, not a current processor. And at Intel, if you're watching the Mark Bohr thing, right, it's Mark Bohr, it's a Bohr. No, I didn't say that. What we do at Intel, at each tick or talk, and I'll show you ticks and talks in just a minute, we actually add new instructions, and we try to compute more instructions per clock cycle. So even though the frequency goes down, my delivered performance for multi-threaded applications goes up. So I don't have the benchmarks here, but in short, the answer probably is older processor, higher frequency. It's not computing as many instructions per clock cycle, lower performance, okay? And I do have benchmarks that actually show you that. So I would tell you to opt into the right. Now, if you're using the same vintage, by the way, right? The same vintage, in this case, you're going to do a 6-core processor against an 8-core processor. That 6-core processor might, probably not, but might. Okay, because you're only going to talk about 10% difference in performance in clock cycle, and you're going to add 15% more in cores. So you're probably still going to get outgunned by that, assuming your application is multi-threaded. Okay, you're probably going to still get outgunned, but we'll have to go look at that. But I've seen some results, and they actually do that. So let's go look at what our friends at SolidWorks did for us with the Lenovo C30. Product. And actually, you can go on the floor. If you go into that little cave area on the at the vendors pavilion, they have a C30 running simulation, not PhotoView 360, but low quality images, it's nearly 3 times faster. High quality images, 3.5 times faster, and video images is only 1.5 times faster, which I thought was kind of like, why? Why is it so bad? And then when you go look at the motorcycle. You can see this is kind of what I would have expected, which is that it's 4 times faster, or 6 times faster, or 4 times faster for low image, high quality, and video images. So, adding more cores, if you're doing this kind of work, will dramatically increase your performance. Okay, and again, this is a 2-year-old Core i7 based product. Okay, but you guys probably have 2-year-old systems that you're using today, and so. The thing I really want to leave you with is new software, new hardware, faster innovation. It's a given, okay? And I'll be more than glad to work with you on showcasing that or helping you gain access to a workstation vendor that'll let you pilot that for a little bit. So now the other one that we did is we took a look at, that was ray tracing, which is interesting. But one more thing on ray tracing. Moto, based on Luxology, right? If you go Google Luxology, ray tracing, GPU, CPU, they actually put out a pretty good argument about where's ray tracing best done. It turns out that it's best done on a CPU. It delivers nearly the same performance as a GPU, but it turns out that the algorithms being used when you start to do things like global illumination actually are better handled by a CPU. I don't know the insides of why that is. I can just tell you that there's a number of people that are out there that have done that. And they have tested it and they have looked at it. So again, adding the second processor, if you're doing things like PhotoView 360, probably not a bad idea. If you're playing a game, one thing I'll give you is that Hollywood, right, indoor games, right? Now, if you're a gamer, Dave, what do you care about, speed or quality of the image? I'm not a gamer either, but anybody a gamer? Okay. If you're a gamer, what are you going to care about? How quickly you can run into the jungle with banana leaves? And do you care about the quality of the banana leaf, the image of the? Probably not. You're going through it so fast that you really don't care. Okay. Now, if you go to watch the latest James Bond movie with all the special effects, what do you care about, speed or quality? And Hollywood uses CPUs to do all their ray tracing for all their special effects in all of the video animations that are coming out on the marketplace. And they do it because of the quality. And it's the same in performance, okay? And so that's kind of one thing I want to leave you on ray tracing. So the other thing that SolidWorks did for us is they looked at these flow benchmarks. They had 35 or so. Is that right? Let's see. Where does it say it? 38 different models Ran 75 to 42 hours, and I still have one business card to give out, so we got to get somebody to ask another question. And there was roughly twice as fast as a machine that was really inadequate. It had 16 gigabytes of memory. It had 4 cores, 8 cores total, going up against 16 cores. It was inadequate. And it shows. But that machine, the 5472, is only 3 years old. So now the other thing we're talking about, and this is the HDP 4000 thing. Which graphics do you need? Okay, if you spend all your day in the upper right-hand corner, okay, then all you need is a entry-level graphics card. Okay? If you spend all your time doing things on the bottom right, you may or may not need a higher-end graphics card. I suspect you will, by the way. I think a Quadro 4000 married in with a dual-socket workstation is the ideal configuration to do those ski goggles, okay? Because the ray tracing is all being done on the CPU, but the actual display of it is going to need a card with lots more memory. Hence, you'll need that Quadro 4000 because of the memory that's out there, okay?
If you're doing the SolidWorks RealView, that all runs in GPU memory?
No, RealView runs on, yeah, that's a true statement. But RealView, to be candid, if you can use HDP 4000 and be fine, okay? So, and again, you got to be paying attention to what you're doing, all right? If you go to the Caddy study, if you download the Caddy study, what they'll say is that if you err, and this is an error, if you err to the side of highest quality, right, at that point you'll probably need a big graphics card. But if you took the quality button and you moved it down just a little bit to where you visually won't see any jaggies, but the quality of the image is not perfect anymore. It's like a stereo, right? I can spend $10,000 on a stereo, or I can spend $1,000 on a stereo. This is that story. It's just like buying the $1,000 stereo and thinking you're still seeing or hearing the same thing, okay? But the difference in performance that you get out of it is substantial. So you have to, don't just default, go change and play with your settings to get the best performance you can. We've talked about solid-state drives. One of the questions that always pops up with solid-state drives is, Wes, it can't possibly last as long as a hard drive. Okay? Well, I don't want you to own a workstation more than 5 years, and our solid-state drives will last more than 5 years. Okay? So it'll last for the life of your workstation. Will it expire before a hard drive? I have no idea. Will the solid-state drive offer you better performance? I can say yes. Okay? So there are some really cool things. Is it worth the extra money? I would say absolutely that you should be able to do that. And so when you put all those things together and you take a look at different ways of configuring the system, what happens, right? Render times for photorealistic images goes down. Simulation for complex systems becomes easier. Drawing updates, file opens, Boolean operations, they all get better. And that's kind of what we've been working on with SolidWorks. So now we're going to go talk about what's next, okay? From an Intel perspective. Yes? Pardon me? Yeah. Uh-huh. Yeah, and I can cut it in half. What should you request? A dual processor, Intel Xeon-based, Xeon 2660 to a 2670, and if you really want to go up to the top, 2687W. Okay? Yeah, go for it. For flow, more cores. Well, actually, in timeout, more memory. Yeah. No. You're probably thrashing yourself to death. Yeah. Mm-hmm. And the other thing you want to do is go look at solid-state drives, because as you start to thrash, having a solid-state drive there to act as a cache is a great thing. And I can say that because MSC Nastran is an example of very old code. It writes a lot of intermediate results, to a disk. Doing it with a solid-state drive is a great benefit. So memory, solid-state drives, But you're crazy not, if you're doing flow and you're not using a second processor, you need help. Pardon me? I don't know what you're talking about when you say it's being done on the network. No. But you're running your simulation local on your Core i7, right? So where are you running it? We'll talk offline on it because I don't want a rat hole on that one. But if you're not running remember we talked about the cloud and being the panacea to everything, right? You should be running your simulation locally because it'll give you a more interactive, closer to real-time environment. Unless your flows are absolutely outrageous, in which case they're taking you back to the server because they're going to try to get you to scale across more cores on the server. I don't know the answer, but it's we'll talk offline on that. Okay. All right. So that's the fourth card. And Dave, is your name on one of those cards? Okay. I just need a business card from you or something, and we can go that direction on that one. So at Intel, we have this model. It's called TikTok. Now, Intel, by the way, is not we're not a solutions company. We're a silicon company. TIC is when I introduce a new manufacturing process, okay? That means I'm going to go from 32 nanometers to 22 nanometers to 14 nanometers to 6 to 4. That's what we do with TICs, okay? At TOCs, we introduce new microarchitectures. New microarchitectures means more instructions per cycle, right? It means new technologies coming into the processor. And you'll never, we did this once, this is why I can say never. And never is a bad word, but this is a true one. We will never do a new manufacturing process and a new microarchitecture at the same time, right? It's the old engineering problem, or it's the math problem from when you were in college, right? It's kind of like you have too many unknowns and you'll never solve it. And so we did that once. It was painful. So we will do a TIC is a new manufacturing process, and a TOC is a new microarchitecture on that one. So the TOC, the new microarchitecture that comes out later this year in our entry-level workstation, is based around 22 nanometer technology. So that's kind of that's cool because what that means is new instructions like fuse, multiply, add, which is good for CAD. Is going to be part of what that new microarchitecture is all about. It means increased efficiency. It means lower clocks. But because I'm doing more instructions per cycle, it means more performance. Okay? And it means more cores. Okay? You'll see that our roadmap is flush with cores. And it's good for some people, and it's not so good for other people. As long as we can keep our clock cycles where they need to be to keep CAD users, which are very single-threaded minded, happy, we'll be fine on that one. And we have a roadmap that does that. Okay, so let's go talk about processor graphics, right? So, if you looked at Intel, if you ask me, Wes, is processor graphics a worthwhile investment or even of my time to evaluate? I'd have said no. Even 2 years ago, I'd have said no. Even a year ago, I might have said, well, it's almost there. Today, I think it's there for entry-level graphics. If I listen to my buddies at SolidWorks, I think they'd tell you it's here on that one. And if you take a look at where we're going, and I'm going to give you a glimpse of where we're going near term, and then where we're going in a couple of years, we're going to double it again. So I'm excited about what we can do with processor-based graphics. If you're just doing CAD kinds of work, if you're really not doing the animation work or the simulation or the ray tracing work, then an entry-level workstation with processor-based graphics is going to be ideal. The other thing that makes me excited about processor graphics at Intel is the fact that because you can put it all on a real thin form factor, it's going to allow you to move into different form factors that you might use, right? And I'm not here to say that you're ever going to design on a tablet because I don't think you ever will, okay? You might review on a tablet, but I don't think you're really going to design on a tablet. But there are some cool things that are popping up in terms of what's going on in terms of new form factors. So on the left is the next gen, and on the right is our HD P3000 graphics, which was the predecessor to P4000. But, I don't like to show what we were just now, but I'd rather show you what you might actually have on your desktop. And so this is hot off the press, came to me this morning. And again, the one on the left is the new one, and the one on the right is the old one. And it looks like the one on the right's winning, which I don't quite understand why that is. But you'll see that we catch up. And this is Real View turned on, by the way. This is a real simple, small image, but it's the only one that we have from SolidWorks. And then we jump into another part of their benchmark, which takes a look at the living room or whatever that thing happens to be called. And then you'll see that we're done. And the one on the right is still going. And it's going to go for a while, okay? Roughly 3 times the performance of what was here just last year. I like that. And I think that's pretty good for processor-based graphics. I think it's pretty good for the people doing small and medium assemblies. So I feel pretty good on that one. So the next-gen microarchitecture increased CPU performance and improved responsiveness, because those are the instructions that we're paying attention to. The other thing that you get out of a workstation is memory error correction, ECC. How many people think they need ECC or don't need ECC? Don't need it. How many people don't need ECC? Who knows what ECC memory is? Okay, so ECC memory basically says it's going to do a parity check and it's going to check whether or not the bit's right or not, right? Why do you care? The best example is to use a portfolio analysis. I was doing a portfolio analysis and I thought I had $2 million and a memory error occurred and I was unaware of it, but it said I only had $19,000 because it flipped a bit. It made a 0 into a 1 or a 1 into a 0. That's a bad thing, right? I just think I lost a lot of money. And if I was on the 15th floor of a building, I might have done something irrational. Okay? Not a good thing. The point there is that you don't know whether or not you had it or you didn't have it. Okay? That's the point. And if you're professionals and you're delivering work, you want to be using a workstation that supports ECC memory. It's just, I don't understand why you wouldn't want to do it. Yes, it costs more. And yes, it will slow you down just a little bit because there is a penalty that you pay. We're talking 1%. Do you care about 1%? Probably not. Do you care about do you care about the benefit of it? Yeah, because if you spend 2 hours working on something and you didn't save it, it's going to take you 4 hours to recover it after you have the memory error. Okay, do you want ECC memory? Probably. I showed you the graphics performance on that one, and then so this is really server-based, but maximizing node density. So the future's bright at Intel. If you marry a Intel Xeon with vPro technology along with Intel solid-state drives, you end up with an opportunity to do some really crazy things that you've never thought of doing before. Is it good for you? Absolutely good for you. Do you want an Intel Xeon based processor? I only hope you do. If you're using desktops, you might want to question why you're using a desktop as opposed to a workstation. Workstations are built for professionals. They're typically based on Intel Xeon processors. Every once in a while, you can get one with a core if that's what you choose. But you're only going to save a couple dollars, and I would tell you to err to the high side on that one and benefit from the extra performance, the extra productivity. This is my cheat sheet in terms of what's in a workstation. An expert workbench. I call it an expert workbench. I live in Texas. We don't have basements. I used to live in Cincinnati. We had basements. In my basement, I had a workbench. That's where I kept all my tools to go build things or break things, but mostly build things, right? And when you take a look at what SolidWorks is doing with their premium and professional products, those are tools. And if I can have all those tools on my workbench and use them all the time, then I will be more productive. That's why I call it an expert workbench, okay? The Essential Workstation says it gives you almost everything that you need, okay? Not quite everything, but it does give you more. And then you can do the entry-level workstation because you're just stepping up from a desktop, and it's going to be more capable than a desktop. It's just not going to give you all of the features that you have in your workstation. So here's the cheat sheet when you go talk to our buddies downstairs. If you go see HP, the expert workbench is the Z820 or 620 series. And if you go to Lenovo, it's the D or C30. And actually, if you go to the customer pavilion where SolidWorks is displaying their simulation package, you'll see the C30 in action, and then the T76 and 5600. All of those are dual processor capable workstations. Those are the right things if you're doing anything around ray tracing rendering or simulation. And then you can move down. Yeah, it gives you more capacity than the entry level, but those are the S30s, the T3600s, and the Z420s. All great products, just not nearly as expandable, which is what the graphic in the middle shows you. And then at the bottom, again, if you're using a desktop, this is a great desktop replacement on this one. There's some automotive companies, by the way, that are looking at this particular breed of a workstation, and they have what they call technical desktops. They're not CAD guys, but they're technical desktops. They're doing reviews and collaboration. And because of some of the optimization that you get out of HDP 4000 graphics, we're finding that they're moving from a technical desktop, client-based, and into an entry-level workstation because of increased productivity, okay? And they're talking big numbers, like 20 to the tune of 20,000 units. And those are, I mean, that's a massive investment on their part. Purchasing in particular says, why do I want to go spend $50 more or $100 more per workstation? Engineering people come back and say, here's why you need to do it. They talk about productivity and the impact that productivity has. I've got time for some questions or arrows if you choose to throw those. Yeah.
You have found motherboards.
What, pardon me?
Intel motherboards.
Yeah, we can talk motherboards. What would you like to? I mean, I'm not an expert there, but we can certainly. I mean, what do you want me to say about motherboards?
When you look on the Intel side, when you look at all the dual Xeon motherboards,
Yeah.
all of them say server.
Uh huh.
And I don't think I actually saw one that says workstations.
Yeah.
The question is, how do you pick a motherboard if you're going to build your own workstation?
I would tell you to go to Supermicro.
Where?
Supermicro they also build motherboards. They might serve you better in terms of giving you a workstation motherboard. You'll find that some of the other vendors downstairs that aren't the big three, but others also use Supermicro or Asus, and you can get single processor or dual processor workstation motherboards, and they're very good about helping you understand that. If you're going to get a card, so if you send me an email, I'll be more than glad to point you in the direction of some Intel-based motherboards that'll do that, because they're there. It's just that it's not the focus of that particular group to build workstation motherboards. We look to Asus and Supermicro to go do that. So, any other questions? Wait.
I know you're not a big fan of overclocking,
Yes, I'm not a big fan of overclocking. That's true.
but at work we had a benchmark. We bought an i7. We overclocked it. It was from the K family, which allows you to overclock with 10%.
You can do that. And you'll get 10% more performance. Okay? Absolutely. For SolidWorks, you would definitely get 10% more performance if you overclocked it by 10%.
Yes, and so it was better than buying a Xeon in the same price range. I mean,
Just depends what you want to do. A Core i7 overclocked is an interesting solution. The guys from Box Technologies have done an outstanding job of engineering that solution. And if you're going to go overclock, there's a few companies that you do want to buy overclock solutions from, and they would be one of them. They do a tremendous job of engineering in reliability, which is what you really want to be paying attention to when you overclock. You want to make sure you engineer in reliability, and you want to make sure that whoever you're choosing it from, that you go that path. Okay, that's what I would do. I mean, I don't know what else to say. I'm a big believer in taking standard parts and trying to get the most out of it, okay? I'm a big believer in saying, look at all of the investments that you need to be making and say, is that the right place to go make the investment? I'd love you because you're buying those overclock solutions. I think they're great. I'm not going to tell you not to buy them. I think it's awesome. I think there's lots of investments out there that can improve your performance, okay? Does that help? I mean, I don't know what else to say. So, any other questions?
Last graphic showed the E2600 with 4 DDR3.
Yeah, good question. Yeah. Okay. So that is a great question, and I'm glad you caught that one. Okay, because one of the things that you all need to be paying attention to is when you're buying a workstation or even a desktop PC, you want to make sure that you populate your memory channels evenly. If you don't, you're not going to get the best performance you can. Okay. Yeah, that's a quad channel. The Xeons are all quad channel, and the entry-level workstation based on a core part with some other technologies around it, support ECC memory and whatnot, is a 2-channel part. But quad channel, 4 times the memory bandwidth on that one. So double the memory bandwidth of what you're going to get out of an entry-level workstation. Remember we talked about the uncore technologies? Oh, that's part of the uncore technology. It just gives you greater, I mean, we said it moved data around faster. That is why it moves data around faster. So, but good catch. But the real one that I really want to make sure that everybody's up on is don't go and buy a 4 gigabyte stick and you want to get to 16, or you want to get to 8 gigabytes, buy 2 4 gigabyte sticks and leave the other 2 slots empty. That is a terrible idea. Okay? If you want to get to 8 gigabytes or 16 gigabytes, populate your memory channels evenly. That's the best way to get the best potential performance that you're going to get out of that processor. Thank you. So, yeah.
How are you with the CPU benchmark site? What do you think about the results?
Your question is, what do I think about the standard benchmarks? Is that a better way to say it, maybe?
Yeah.
I hate standard benchmarks. This is what I think. Here's my attitude on standard benchmarks, okay? And Caddy is a perfect example. The guys that reseller in Chicago, they took a day in the life of a CAD reseller, and we were able to look at what it really means. Standard benchmarks are awesome for testing the edges of what is possible. Okay, so if you want to test the edge of what is possible with a graphics card or a CPU, a standard benchmark is an awesome solution. So if you want to see how many gigaflops you can get out of a processor, go look at LinPack. Okay, it's an awesome solution that says here's what. If you want to go look at what a PC is capable of, Sysmark is a great idea. It's going to show you what is possible. It's not clear to me that it's going to give you everything that you get in the day in the life of. It's going to give you the edges, which you don't live at the edges, okay? And you can buy for the edges, but I really think you need to be a little bit more cautious in that, is don't get, because otherwise you're going to make investments that you might not want to make, okay? And that's my take on it. And we're working with the committee to come back and say, what's the day in the life of, okay? But everybody, including Intel, wants to go say, well, here's what's possible. Okay? That's just because benchmarks are nothing more than specsmanship, okay? The way I look at a benchmark is it's a ticket to entry. It's the dance card, right? Do you want to dance with me? Look at what I can do for you, right? And then beyond that, that's about all you ought to look at, a standard benchmark. Is this the dance card? Yeah. I think I'll look at you, okay? And when you look at me, then make a decision about, do you want me? I wouldn't make a decision, do you want me, based on a standard benchmark, okay? Again, in the business, 32 years, in the old days, we would do real benchmarks, okay? That's old school, but that's the best way to get the best solution for you. Yeah.
The biggest problem with benchmarks, and I used to do benchmarks for SolidWorks magazine, is they don't really represent your world. They typically run on a machine with nothing else running. So you don't have email running, you don't have antivirus, you don't have control of lighting conditions, how many light sources, everything else. They don't really reflect the benefits of your graphics card. Because in reality, once you get about 30 frames per second where it's fairly fluid, anything faster, we try to trace than that, will boost your benchmark performance, but you won't see the benefit if you're actually using it. So all the benchmarks will always have the 5,000, 6,000 graphics cards being killers, but you won't see the benefit over a 2 or maybe a 4 at all.
And that's what Caddy found, is that, they had a 6% difference in performance between an entry level and a high-end graphics card. And I'm not saying not buy it, because you do need it. Given the right situation, you do need it. If you're doing Adobe photorealistic, or if you're doing Adobe After Effects and/or Premiere Pro, trust me, you want the biggest graphics card you can get your hand on. If you're doing CAD, I don't know. I'd give a second thought on it. I would sit there and say, buy low and move your investments around to other parts of the solution. But buy right. Not buy low, but buy right. Right? A Quadro 2000 is probably not a bad card. It's slightly overkill, but not a bad card from that perspective. There are some things that all of the CAD companies are doing that are going to recognize what more GPU technology can do for it. So positioning yourself for the future, probably not a bad idea. Okay? Above that, I don't know. So it's hard for me to tell you not to buy that. But evaluate what it is that you need, test it, and go from there. So there are only 6 of you here. Everybody write down my email address. If you don't get, and I want you to send this to me. And there's only 6 of you, so this is easy. If I get more than 6, I'm going to disallow it because you sent it to everybody, and you won't get it. Okay? You'll all get a solid state drive. Okay? I want to thank you guys for coming and sharing and being a participant in this. I wish there had been more of you, and I hope this was good. I like to do these things. I hope this was good, enjoyable, entertaining sometimes, and look forward to seeing you next year, same place, same time, different city. Thanks, guys.